Okay, we're going to be looking at a unit on time, and we start by looking at latitude and longitude. Before we get to that, which is looking at a point anywhere on the Earth, let's firstly look at our work on the number plane. Any particular point here, we could define it by how far it was horizontally from some starting point and how far vertically it was. So for these coordinates, we always list the horizontal part first, then the vertical. So that particular dot is the point 3, 1, because from the origin we went across to the right by 3 and then we went up 1. Okay, similarly, same sort of thing on a map, not that we use paper maps much anymore, but if we were trying to find Hunters Hill Girls High School, we'd do the horizontal, we'd get to D, then we go to the vertical, which is 4. So that happens to be at the grid reference D4. And we're going to follow very similar ideas when we look at latitude and longitude, which will cover a position anywhere on the Earth. Okay, when we come to try and find a position somewhere on the Earth, because it's a sphere, we've got a bit of a problem. You know, how do we create a sort of a two-dimensional grid and sort of somehow wrap it around a globe? Well, what we start with, and we'll explain this more later, but we start with two lines. One is going to be a vertical line. We'll talk about that later. That happens to pass through London. We've also got the equator here. And basically, those two lines are going to create, so let's see them here on the world map. Those two lines are going to create our X and Y axis effectively. Okay, so everything is going to be measured from this point here. We're going to work out how far east or west we come from that position and how far north or south. Now it so happens, just because it's a sphere, it's a pain in the neck to try and work out and to think about, but we measure things in terms of an angle. So you can see at the top of the circle, you can see you could either, so basically there's 360 degrees in a revolution. And what we do is we basically say, well, we can come up to 180 degrees to the east, or we can come up to 180 degrees to the west. And you can see that'll be either up to 180 degrees to the east or up to 180 degrees to the west there. With the northings and southings, as we call them, basically if you were to start at the equator and move up, you can only move up to 90 degrees till you hit the North Pole, and similarly you can only go down to 90 degrees to hit the South Pole. So basically, it's very hard to show on a map. Basically, a two-dimensional map will tend to exaggerate the size of these areas near the pole. So you can see here we're cutting this map off at 60 degrees south. We go a little bit further to the north because there's a bit more land in the northern hemisphere there. Now, to give you an idea of what's actually happening with these degrees, imagine taking this sphere, okay, and imagine trying to find the centre of the Earth, okay. Now if I wanted to work out the position of a particular point, so let's mark that line there in the equator. We'll talk about what they're called later. If I wanted to say work out the point, the coordinates of that particular point, what I've got to do is draw a line from the centre of the Earth through to the origin. Then imagine a line that comes straight down to the equator. I draw a line there. I'd need to measure that angle. That will tell us how far round to the east we need to come. And then I also need to draw another line from the centre of the Earth up to that point. I need to measure that angle, and that'll measure how far up here we come. Okay. These the ones that go east and west are called the longitude. The ones that go, so the east-west distances. The ones that go how far, measure how far north or south you are, they're called the latitude. The way I remember those is, this is sort of a bit like altitude, which is like your height. That's the easiest way to remember it, and the other one goes east-west. Okay, just some terminology that comes up every now and then. Basically, if you were to look at any circle on the surface of the Earth, it's either got the same radius as the sphere, what we call a great circle, or it's got a slightly smaller radius, which is called a small circle. And the easiest way to imagine that is, imagine taking an orange, say. If we were to cut it exactly in half and open up those halves, you can see that the half that you opened up would have, if I'd drawn it correctly, would have exactly the same radius there. So that's what we call a great circle. If, however, I cut it off to one side here, you notice that the cut, doesn't matter whether you had the big part or the smaller part, but you can see that its diameter or radius would actually be smaller. Okay, so it's some old technology. I don't know how much it's going to occur in the course. Importantly, things like the equator of the Earth, okay, that's going to be a great circle because it goes all the way around. It's got the same radius. And also, when we talk about lines of longitude or meridians there, they go right around. They're also great circles. But when we talk about these other lines of latitude other than the equator, all of those are going to be small circles. Okay, so basically the lines of latitude are very easy to sort out. You start with the equator, which is the only one of these lines of latitude that's a great circle. Obviously that's halfway between the North Pole and the South Pole. We then basically measure, again, imagine the centre of the Earth would be something like that. So say, for instance, if we wanted to work out what this line of latitude is, we just work out, so draw a line from the centre of the Earth to the equator, another line up to any particular point. If we measure that angle there, that'll tell us the parallel of latitude. So at a glance, that angle looks like it's about, say, 40 degrees. So this particular line here would be 40 degrees north. Okay, and that's how it's worked out that way. And again, any point, even though it's very hard to draw in 2 dimensions, so that point there, we draw the point sort of south of it on the equator. We'd measure the line from the centre of the circle out to there, and another line from the centre of the Earth up to the point. And again, that angle should also be 40 degrees. Very hard to work in, spherical geometry. Working in circles, very hard to understand. Now, any line that goes from the North Pole down to the South Pole, and there's an infinite number of them, all of those are going to be what we call lines of longitude or meridians of longitude. Again, lines of longitude, I guess, is the more common sort of modern term. Meridians is an older term there. Now, we've got a problem. Which one should be our starting one? Because they're all equal to start with. There's no reason one should be more important than the other. Well, if you go back, back to the 1800s when so 1884, this was decided there. The predominant power in the world was Great Britain. Okay, they had the British Empire, and so they basically got to decide how it was going to be sorted out. And if you were to go to London, so now so London, sort of just slightly there. Greenwich is now a suburb of London, but you know that Buckingham Palace is where the Queen and any future kings live at the moment. But back in the day, it was a different palace. It was down on the Thames River at Greenwich. Okay, it was called the Royal Palace, and up the back of the palace, they had the Royal Observatory. Okay, you can actually go there. I've actually got it's an old analogue video, so I can't easily upload it. But basically, I've got a picture of myself outside the Royal Observatory in Greenwich, and they've actually got this brass line that comes outside the fence, so you can actually stand with one foot in both the eastern and western hemispheres. So anyway, because England was the prime power at the moment, the meridian that runs down through the Royal Observatory at Greenwich, that became the basic, where everything was measured, east or west from that point there. So originally it was called the Greenwich Meridian, because it runs through the Royal Observatory at Greenwich. That then, it was also where all time was measured from, so you might have heard of Greenwich Mean Time. It's now called, after who knows how long it was called GMT for, but more recently it's called basically Universal Time. This is actually French. I think it means Universal Time Coordinated or something like that, but in French. Okay, so that's why that particular line, the Prime Meridian or the Greenwich Meridian, passes through Greenwich, not through London itself. I mean, Greenwich is only like about 10 kilometres down the river from the centre of London, but yeah. Okay, that's why it's called the Greenwich Meridian. Okay, just to help us practice some of this work here, what we're going to do here is just practice drawing a particular position on the Earth. So we start with a circle which is two-dimensional, and to try and make it look a bit sphere-like, draw a line not straight down the middle, draw it sort of at a bit of a bow. I normally do mine to the left, but it doesn't really matter. And then draw the equator, and again sort of bow it down a little bit. So it still sort of, starts at the north and the south ends. It has ends at the east and the west ends, but by putting that bow in, it sort of gives the impression of being, three-dimensional. So a particular point that's 50 degrees north and 20 degrees east. And you notice here, with latitude and longitude, we normally put the northings or southings, so we go the uppy-downy bits first and the lefty-righty bits after that. So we want to go up 50 degrees north, so there's 0, there's 90, so 50 would sort of be about there. Then we want to go 20 degrees east, and again, just a reminder that you go 180 degrees to get right around to the back side of the circle, so sort of 20 would be about there. And if you like, you can sort of put something like 20 degrees east and 50 degrees north there. The alternative is to draw the lines of latitude and I haven't drawn that very well then, have I? If I'm going to draw my meridian down that way, so that's probably a better way to go about it there. Okay, and again, getting the idea that you've come either 20 degrees around to the right for east or 50 degrees up for north. Okay, so again, drawing in our prime meridian and our equator, we want to go 30 degrees south, so 30 degrees, so there's 90 degrees, so 30 is about there. Again, if you like, draw in your parallel of latitude. 30 degrees east, again, all the way around to the back is 180, so sort of 30 is about there, say. So there's our particular point. Again, that's going to be 30 degrees east. You can sort of draw an arrow 30 degrees, and again 30 degrees south. You can sort of put an X or a dot, whatever you like there. Okay, again, starting with our prime meridian and the equator, we've got 10 degrees south, which is sort of about there. This time we've got 20 degrees west, so we need to come this way. So it's sort of going to be about like so. Again, we can just put the C there if you like. Again, drawing our two baselines. This time we've got 50 degrees north, which is about there. Again, we've got 20 degrees west, which is about like so, sort of about there. 10 degrees north, so not too far north there. 45 degrees east, so maybe about like so. Again, drawing our baselines first. 65 degrees south, which is a fair way south. And 5 degrees west, not very far to the west. So there's our point there. So it's a bit of practice, and you can see how drawing those bowed lines gives the impression that a two-dimensional drawing is actually three-dimensional. Okay, so we've got a diagram, and this thing here is the prime meridian that we've talked about, and this line here is the equator there. Okay, so we want to find which letter is 55 degrees to the south. So you can see here's the 55 degrees south line there, and we also want it to be 55 degrees to the west. And see, it's not drawn very well, but that angle in there is 55 degrees, which means that this particular line is the 55 degrees east line. So we look for where the 50 degrees south and the 55 degrees, let's just write that in there. So that's 55 degrees east. So where those two lines there is the letter W. Now we've got 30 degrees north, which they've marked here for us, and 55 degrees east, so they're that same line there, so they're meeting there at S. Okay, we've now got 75 degrees north, which is that same line of latitude. We've got 0 degrees east, and look, quite often that'll just be written as 0 degrees. So that's the prime meridian, and so they meet here at P. 0, 0, that's where our two main lines, so the prime meridian and the equator meet. They're meeting here at T. Right, our part E, we've got 0 degrees, which is the equator, so that's a north or south, the first one. So we're on the equator, and then we're going to 55 degrees east. So the 0 degrees is the northing, southing, and the 55 degrees means we come round to the right. That puts us at U. And lastly, we've got 75 degrees north, which is this line of latitude, and 55 degrees east. They meet there at Q. Okay, we've got Sydney's coordinates are 34 degrees south, 151 degrees east, and Tokyo's are 35 degrees north, 139 degrees east. Okay, so let's firstly do it on the sphere, but we're going to find this a lot easier if we just do it on an ordinary number plane. So we've got our prime meridian here, we've got our equator like so. So Sydney is 34 degrees south, so about that sort of height there. 150 degrees east, it's actually around the back here somewhere. Okay, so, but let's just sort of draw it over here, sort of on the extremity there. Okay, so there's Sydney, just there. Now Tokyo, it's 35 degrees north, so it's, this was 34 degrees south, 35 degrees north, so very similar, but one north and one south. But it's only 139 degrees around to the east, so Sydney was 151, so Tokyo here is 139, so there's Tokyo. But as you can see, that's not a very clear way to draw it. If instead we draw our ordinary sort of, a flat diagram there, so Sydney is going to be 34 degrees south, a bit like minus 34. It's going to be 151 degrees to the east, so there's Sydney. Tokyo is going to be 35 degrees to the north, and it's going to be 139 degrees to the east. So you can see there we've got a much clearer way to work out our questions. So the difference in their latitude. So latitude is the basically the north-south bit there. So you can see that because one's 34 to the south and the other's 35 to the north, we've got to add those numbers there together. So the difference in their latitude is going to be 69 degrees. And what we'd say, if the question had said something like getting from Sydney to Tokyo, how many degrees north do you need to go? So you'd need to travel 69 degrees north, or the other way, 69 degrees south. The difference in their longitude, you can see here, because they're both to the east of that origin point, we need to subtract those two values there. That's why it's so important to have to draw yourself a little bit of a diagram to work out whether you need to add or subtract the two numbers. Okay, which city is further west? Well, you know that west is over this direction here, so that's still our north, east, south, etc. So which one is furthest to the west? So you can see Sydney's further to the east, so obviously Tokyo is further to the west. Okay, Goulburn has coordinates 34 degrees south, 149 degrees east. If Armidale is 4 degrees north and 2 degrees east of Goulburn, what are its coordinates? Look, the safest way is to draw yourself up a little number plane there. So Goulburn is 34 degrees to the south and it's 149 degrees to the east. So there's Goulburn. Now Armidale is 4 degrees north up there, so it's going to be at 30 degrees. So what we've done, look, we've gone up by 4, but really we've subtracted 4 from the amount of southing, if you like. And it's also 2 degrees east, so we need to go another 2 degrees, and we need to add 2 to make that 151. So you can see on the diagram that's relatively straightforward. Alternatively, starting with the coordinates of Goulburn, we start with 34 degrees. Because we're going 4 degrees north, which is the opposite of south, we're going to subtract the 4 degrees. oops, 149. Because we're going further to the east, we're going in that same direction, we're going to add the 2 degrees. So you can get that 30 degrees south, 151 degrees east. But look, it's just safer to draw a diagram. You're less likely to make a mistake there. Okay, a simple matter of matching each of these letters to the different latitude and longitude. So to find Moscow, we need to go 55 degrees to the north, which is sort of going to be about that height, and 37 degrees east. So there's 30 degrees about here. So if you sort of match those two up there, you're going to get to G there. To find Athens, we want to go 38 degrees to the north, which is sort of about there, and we want to go 23 degrees to the east, which is about there. So that'd be 30, so about so. And if you match those up, I think we're going to get to D. It's not very clear there, but I'd say that's D. I think H is just there. Okay, Perth. So we want to go 32 degrees south. So this time we're going down here. So there's 20, there's 40, so 30 about there. Well, look, I think we all know where Perth is there, but let's just check. 116 degrees east again. So there's 0, there's 120, so 116 is about so. So that's the letter A. Alexandria, so that's in Egypt, so 31 degrees north, so we're sort of about there, and 30 degrees east, so we're sort of there, and that's going to lead us to this point here, H. St. Petersburg, which is also in Russia, so we're 60 degrees north. Well, not surprisingly, there's only one letter it could be, but let's check again with 30 degrees east. So again, those two are going to line up at B. And Lima in South America, oh, I went straight to it, I shouldn't have cheated. Okay, so there's 0, so there's 10 degrees, so it's about that sort of height there. And it's going to be 77 degrees west, so there's 60, there's 90, sort of going to be about in there. So as you can see, we get the letter K. Okay, so we need to find the coordinates of different points on here. Okay, so again, it's not a great diagram there. So they show us this line right on the very edge, this meridian here. That's going to be the 110 degrees west. It's not shown very clearly, but this one in here, that's going to be the 75 degrees west. And then this one here is going to be the 40 degrees west. Again, not drawn very well there, but sort of this line here, this 30 degrees is trying to indicate that is the 60 degrees south line of latitude. This one here is 45 degrees north. So if we want to find V, so V is just here, so again it's not drawn very well, but that's meant to be the equator there. So it's going to be 0 degrees. Look, you could write 0 degrees north or 0 degrees south, that's fine. And it's on the line of, or the meridian of longitude 75 degrees west. U, which is just here. So again, it's still on the equator, still on a northing or southing of 0 degrees. This time it's on the 110 degrees west line of longitude or meridian. R, which is just here. So this time it's up north of the equator, so it's 45 degrees north. And again, it's on that 110 degrees west meridian. And X, which is just down here, so it's south of the equator, it's 30 degrees south, so on this line of latitude. And again, it's on that meridian 110 degrees west. Okay, we just need to find the difference in latitude. So latitude is the northing-southing one, so we can just ignore the longitude, the easting-westings. Okay, so if we want to work out the difference in latitude between Shanghai and New York, you can see one's 31 degrees north, the other one's 40 degrees north. And again, look, if you liked, you could draw a diagram. So there's your 31 degrees north, there's the 40 degrees. Because they're both in the same direction, we need to do subtraction. We need to find the difference. So 40 take away 31 is equal to 9 degrees. Look, the importance of that is that they've both got a very similar climate, okay? They're both going to be fairly cold in winter, and relatively north of the equator. So it doesn't sound much, 40 and 31 degrees, but it's actually There's not that much of the Earth that's that far away from the equator. Again, it all gets down to funny circle things. Okay, again, Nairobi and Bangkok. One's south and one's north. So if you like, one is just 1 degree south and the other one's 13 degrees north. Because they've gone in opposite directions, we need to add those angles to get 14 degrees. Again, relatively small number means they've got a fairly similar climate. They're both relatively close to the equator, so a tropical climate basically. Okay, again, ignore the eastings, westings. Moscow and Russia, one's 55 degrees north, the other one's 51 degrees north. They're both north, so we're going to subtract. And so you can see they've got a difference of only 4 degrees, which is a bit bizarre because we think of Moscow being a much, much colder climate than London. Basically, it's because London's on the Atlantic and it gets the Gulf Stream, so it's got a much milder climate than its latitude would indicate. Okay, so this time we're looking at the difference in longitude. So this time we're going to ignore the northings and southings. We're just going to have a look at the longitude there. And again, the rule is if they're heading in opposite directions, just add the numbers there together. So you can see they're fairly far apart. Look, if you prefer to draw a diagram, so one is 19 degrees to the east, the other one's 80 degrees to the west there. So again, they're heading in opposite directions, so add them together. Okay, again, ignore the northings. So Athens is 23 degrees east, Paris is 2 degrees east, so they're both in the same direction, so we've got to subtract to find the difference. Again, for Havana and Mexico, they're both to the west, so let's subtract those angles to find the difference, and we get 17 degrees. Okay, Broken Hill is 7 degrees due west of Dubbo. If Dubbo's position is 32 degrees south, 148 degrees east, what is Broken Hill's position? Okay, so because it's due west, there's no difference in latitude. Basically what we're doing here is we're starting at 148 degrees. We're wanting to go 7 degrees to the west, so you can think about that as minus 7 degrees east if you like. So we need to subtract 7 degrees from that to get 141 degrees east. Okay, Ipswich is 2 degrees north and 2 degrees east of Moree. Okay, so so to find Ipswich, what we're going to do is start with Moree's latitude of 29 degrees south. Look, because this is going north, it's effectively, it's the same as minus 2 degrees south. So we're going to minus 2 degrees there. That'll tell us how far to the south it is. Starting with that 150 degrees east. Look, it's another 2 degrees east, so we need to add 2 degrees there. So that's going to give us 27 degrees south, 152 degrees east.